Probably a lot of you remember this. NASA had done a test of planetary defense. What happens if there's an asteroid out there that's heading for Earth? Now, of course, we all know that you hire Bruce Willis and he goes and blows it up. But we don't really know that that's going to work. So they decided we need to do something about this. So there was a project of NASA called DART where they basically smashed a spacecraft, that one on the lower right corner there, into the smaller of a binary pair of asteroids. The one they're smashing into is called Dimorphos. It's orbiting around the larger asteroid there, Didymos. And the reason they picked that was if you smash into it, the idea was you change its momentum, you're changing its path. You could tell how you did based on the orbital period. You can't actually observe these directly. Our optics are not good enough. So all they can do is the same way they detect planets around stars. Essentially, you look in the area where you can just kind of see a blob of light. And when the smaller Dimorphos gets in the way, there's a dimming, of the light that's reflected off of it from the sun. And as a result, then they can tell what the period is. And so it is actually measurable. So if the period of the orbit changes, then they know they succeeded. So they did a head-on collision with Dimorphos, and that was back in 2022. The goal was to slow it down. So what that would do, by slowing it down, it lowers the orbit. And actually, to have a lower orbit, you have to go faster. So in fact, that speeded up the period. And it sped it up like 30 minutes, 31, 32 minutes, something like that. So it was quite successful. But the thing is, they want to have a mission now to go back and look and say, well, what really happened here? By the way, interesting point here, we don't really know much about asteroids when you get down to it. There's several different types. This shows the actual pictures of what they look like. When we got out there right before the crash, they managed to get good pictures of the things. This was the artist's conception of these asteroids before. I think the Didymos one was probably just a complete fabrication. The little one over there, Dimorphos, that one actually I think was taken from one of the asteroids the Japanese visited, I think Bennu or one of those. So that one is realistic in that it's at least another asteroid, but it's not this asteroid. That's the artist's conception, and that's the actual pictures. You can't really trust artist conceptions, but because they reflect what the beliefs are at the time. And I'm not trying to make fun of astronomers. It's just simply that space is big and far away, and you don't know what stuff really looks like until you get there. And so you make your best guess. Now, what actually happened, though, is that instead of being a hard piece of rock, Dimorphos in particular, was probably what's called a rubble pile. That's official technical terminology, by the way, the rubble pile. Meaning it's just mostly a bunch of loose boulders, probably mainly held together by gravity. They're not stuck together like glue, like clay on Earth or something. They're just pretty much held together by gravity, they think. The impact, when this spacecraft ran into it, it blew 2 million pounds of rock off of it. That's out of 9.5 billion, so it's not even that much, but it was enough to change it. That debris formed a tail stretching for thousands of miles. It looks like that. That's actually the first human-made comet. When people see that in the future, we can say, we did that, thank you. But that's proof that we can do something. We can actually change the way the universe appears. And that's actually a good thing from the standpoint of planetary defense, because if you think about what happens, suppose my left hand here is Dimorphos, you smash into it and slow it down. If it just gets absorbed, then basically you slow it down and you change the kinetic energy, they kind of cancel out. But if material gets ejected, it shoots off. That adds additional force. It basically amplifies the effect of just running into it. And it turned out it did. It's actually like 4 times what the effect you would have had. Anyway, so that's what it looked like after impact. That was about 2 weeks after, and there was no comet tail there before. So the goal is to analyze the aftermath. What does it really look like? They had pictures on the way, because not only did they have pictures of the spacecraft itself, but they had a little CubeSat off on the side taking pictures of the whole thing. But it didn't last very long either. So they don't have any information now, and that's what they want to get. So they want to find out, well, first of all, even the mass of the main asteroid, they don't really know that well. By circling it and really analyzing, they can figure out its mass a lot better. Then they'll know better what the impact was on the system. The shape, what shape is this asteroid in anymore? For instance, if it really is totally a pile of rubble, it could have changed shape completely. If it's a hard rock, it might just have little impact crater. And the real answer is probably somewhere in between. There's probably a bunch of boulders that got rearranged a bit, and some that didn't. And we'll find out when we get there. But they're going to study the magnetic fields, the gravitation. They're going to analyze the compositions, because this craft not only has itself, but it also has 2 little additional CubeSats. They're going to go on land and take samples. And so they're going to actually try to get a better understanding of what's there. I'm going to highlight one thing in the picture here. This is from the European Space Agency. It's their project. Back before this mission, most people thought most asteroids are hard rock. You know, they knew about the rubble pile kind of theoretically, and maybe they knew about some, but they always assumed that. You notice they draw this nice straight line to that little impact crater right there. That's what they were assuming was going to happen. They were assuming there'd be an impact crater. How do I know they assumed that? Well, they made that a lot more explicit in this picture. They drew a line showing their analysis remotely going right to that same hole. The chances are that is not what actually happened, and that's what they want to go see. And I'm not making fun of the space agency. Again, you don't know what's out there until you go. This one, another case where the launcher ended up being a SpaceX Falcon 9. The Europeans are quite upset about this, I mean, because they like to have their own space program. It was kind of controversial, but on the other hand, the Ariane 6, which would have been the rocket to take it, wasn't ready yet. They'd stopped building the Ariane 5, maybe a little too early, and they ran out of rockets, so they didn't have much choice. They had to go to SpaceX to do it. That's typical. The Europeans have kind of fallen behind in launch, but they're still quite active in a lot of other things. Like once you're up in space, there's all kinds of stuff they're doing, and this is an example of that. They're building the spacecraft that are going from Earth out to places like this, as are the Japanese and others. It's not just us. It is actually controlled from Germany. That's after launch. I mean, the launch is certainly going to be run by SpaceX, but once their craft is separated from the Falcon 9, it's all done out of Germany. So the spacecraft itself, 2,400 pounds, 5 feet across in the core, and then 16-foot solar arrays on either side. And then there's a couple of shoebox-sized CubeSats that are going to go and land. And the plans seemed a little fuzzy. At least one of those they're saying is going to land, but maybe both of them eventually will. In all cases, they're not doing that first. They're going to circle around and get as much data as they can. Finally, they'll land one or more of them, and they might even land the main craft itself. They've left that up in the air. They will be analyzing the mineral composition. Just another view of the same kind of thing. Before they land, they're circling around and they're going to coordinate communications between the satellites. They'll really be able to control a lot of experiments. Certainly a lot of the ones related to gravity and that sort of stuff. You can just shooting radio signals and seeing how much gets absorbed. You can learn quite a bit. Timeline, it was launched on October 7th, so it's on its way. So it was a Falcon 9. Now that was an expendable mode. You know, the way the Falcon 9s work, if you want to get the most power out of them, you treat them like a normal rocket. You don't try to recover anything. Because as soon as you try to recover the booster, that said you had to save some fuel behind to be able to land it. And if you land it in the middle of the ocean, you use a certain amount. If you take it all the way back to Florida, then you use even more. And so this is going the other way. They're saying this needed the full power in expendable mode. Now, this is another case where this was actually launched despite the fact that there was a ground hold by the FAA on Falcon 9 launches, except for this one. And the reason is, well, the problem that they were grounding for, it was a second stage problem where it was the re-entry. Normally, you go up and you use the booster and it falls back and it goes back usually to a drone or maybe back to Florida. But then the second stage, normally it goes up, it drops off its payload, and then it has a burst of fuel to slow it down and then vaporize itself in the atmosphere. It was doing that it didn't work properly. That's why they were grounded. But for this mission, that rocket wasn't coming back. It was going off into space as well. So they figured, okay, there's not a danger to people here because the second stage isn't coming back to Earth anyway. So it didn't matter. Anyway, it will fly by Mars. It's actually going to purposely fly right by Didymos, one of the 2 small moons on Mars. They're going to really fly close to that and get some nice pictures. When they get there, it'll be 2026, and they'll maneuver around, do some landings. I think that's it.
Other space-related videos or slide presentations by me are available at the link shown here. That includes a list of videos at my YouTube channel, so you can view them or subscribe for notifications about future videos. These presentations are mostly made as part of the meetings of the National Space Society's North Houston chapter, and the link to that is shown. Topics like these are presented as part of a monthly news segment, and there are also lots of other interesting speakers and open discussions. You can attend in person or online via Zoom. Come join us.